Now, you may have noticed that in our last set of examples, we didn't actually use SOHCAHTOA on the angle theta itself, we use it on an angle of the triangle. This phenomenon is something known as reference angles, okay? So, I'm going to talk about each of the four quadrants. Okay. Now, in the first quadrant, the angle theta, the original angle, is right here, and the reference angle is also right here. Okay. So, in the first quadrant, reference angle is always just the angle itself. In the second quadrant, the original angle theta is right here, but the reference angle, the one you do SOHCAHTOA on, is right here. Okay. Notice that this means in the second quadrant that our reference angle is always 180 degrees minus theta if it's in degrees, or pi minus theta if it's in radians. In the third quadrant, the original angle theta is right here, but the reference angle is right here. Okay. So this means that our reference angle is theta minus 180 degrees in degrees, or theta minus pi in radians. Okay. In the fourth quadrant, our original angle is right here, and our reference angle is right here. Notice the reference angles are always from the terminal side straight to the x-axis. So this means that our reference angle is 360 degrees minus theta, or 2 pi minus theta. Okay. All right, let's do some example calculations of reference angles. Okay. I would like the reference angle for the angle 223 degrees. Now, first we need to know what quadrant it's in. 223 degrees, okay, is bigger than 180 but less than 270. So it must be in the third quadrant, which means that our reference angle is going to be 223 degrees minus 180 degrees, or 43 degrees. And that is the angle we're going to use to calculate the trig functions. In our second example, we're going to look at minus 612 degrees. Now, before we can use these formulas, we need to find a coterminal angle of this that's between 0 and 360. In this case, I need to add a multiple of 360 so that it's positive. And I'm going to add twice 360 degrees, okay, because that gives me the positive angle of 108. So I want to find the reference angle for the angle 108. Now, 108 is more than 90 degrees, but less than 180, so it must be in quadrant 2, so we're using this formula. So our reference angle is 180 minus the 108, which is 72 degrees. Okay? Now, for our next two examples, we're going to use radians. Okay? So, consider the radian measure 17 pi over 3. Now, before we can use any of our formulas, we need a coterminal angle between 0 and 2 pi, or between 0 and 6 pi over 3. Okay? So, I'm going to subtract multiples of 2 pi until this is in the correct range. Okay? And I'm going to subtract twice 2 pi. So this is 17 pi thirds minus 12 pi thirds gives me 5 pi thirds. Okay. Now, 5 thirds, okay, is between 3 pi over 2 and 2 pi. So it's in the fourth quadrant. So we're going to use this formula. 2 pi minus 5 pi over thirds. The reference angle is pi thirds. Okay. One more example. Let's do negative 31 pi over 4. We need to get it between 0 and 2 pi, so I'm going to add a multiple of 2 pi, and in fact I'm going to add 4 times 2 pi, and this gives me the angle pi over 4. Pi over 4 is between 0 and pi over 2, so it's in the first quadrant, which means it is its own reference angle, just pi over 4. Okay. Now, lastly, I'm going to use reference angles to calculate the 6 trigonometric functions of the angle 1,230 degrees. In order to use reference angles, I need to know what the reference angle is. So first, I'm going to subtract multiples of 360 degrees until it's within the correct range. I'm going to subtract 3 times 360 degrees. This gives me 150 degrees. Now 150 degrees is in the second quadrant, so I'm going to use this formula. It gives me a reference angle of 30 degrees. Okay, now I happen to know the 6 trig functions of 30 degrees. The sine of 30 degrees is 1/2. The cosine of 30 degrees is the square root of 3 over 2. The tangent of 30 degrees is sine over cosine, or square root of 3 over 3. And then I take the reciprocals. The cosecant of 30 degrees is 2. The secant of 30 degrees is 2 divided by the square root of 3. And the cotangent of 30 degrees is square root of 3. Now, to turn these into the trigonometric functions of our actual angle, all I have to do is go through and add negative signs. We determined that this angle was in the second quadrant. And in the second quadrant, it had the letter S, meaning only sine and therefore cosecant were positive. So, this means that the sine of 1230 degrees is positive 1/2, and the cosecant of 1230 degrees is positive 2, and all the other ones are going to get a negative sign. So the first step is to calculate the reference angle, then find the trig functions of the reference angle, and then add appropriate plus or minus signs to get the trig functions of our actual angle.